Right now, something is hiding behind the sun. Something that's been traveling for 710 billion years. And in just a few weeks, we'll find out if it's the oldest comet we've ever seen, or something we're not prepared for. On July 1st, 2025, astronomers discovered 3I/Atlas, the third interstellar object to ever visit our solar system. But this one's different, really different. It's bleeding a metal alloy that only exists in our aerospace factories. It's moving on a trajectory so perfect that scientists are calculating a 0.2% chance it happened naturally. And it's arriving at the one moment when we can't see what it's doing. Today, we're breaking down every single anomaly, every coincidence that's too perfect, and why some of the world's top scientists think we might be looking at something that was designed. Let's get into it. Here's what you need to understand first. We've only confirmed 3 interstellar objects passing through our solar system, ever. The first one was Oumuamua back in 2017. That one was weird enough on its own, accelerating in ways that didn't make sense, tumbling through space in a way comets don't normally tumble. Then came 2I Borisov in 2019. That one was more normal, more comet-like. Scientists breathed a sigh of relief. Maybe Oumuamua was just a fluke, just nature being strange. But then 3I Atlas showed up, and it makes Oumuamua look normal by comparison. The moment telescopes locked onto this object, something felt wrong. Not wrong in an obvious way, wrong in a way that makes your brain itch. Like when you look at a picture and can't figure out what's off about it, but you know something is. The data started coming in from observatories around the world. Hawaii's Keck 2 telescope, the James Webb Space Telescope, the Nordic Optical Telescope. And with each new observation, the list of things that don't add up just kept growing. Let me start with the age, because this alone should blow your mind. Scientists estimate 3I Atlas is approximately 710 billion years old. Not 700 million, billion with a B. Our entire solar system, Earth, the Sun, Jupiter, all of it, is only 4.5 billion years old. This object was already ancient, already traveling through the void of space 5.5 billion years before our planet even existed. Dr. Matthew Hopkins from the University of Oxford said, "This is very likely the oldest comet humanity has ever observed." Think about that. This thing has been on a journey since the universe was fundamentally different than it is now. Most comets we know, like Halley's Comet, formed with our solar system. They're made of the same stuff from the same time period. But 3I Atlas comes from somewhere else entirely. Scientists think it originated in the Milky Way's thick disk, a population of ancient stars that formed when the universe was still young. It's a time capsule from an era we can barely comprehend, carrying materials and maybe even structures from the first generation of planetary systems that ever existed. That's already incredible, already worthy of every telescope on Earth pointing at it. But that's just the beginning of why this object has scientists worried.
Let's talk about what this thing is made of, because this is where everything starts to unravel. When you point a spectroscope at a comet, you can see what chemicals it's releasing as it heats up near the sun. It's like reading a fingerprint. Every comet has a signature. Water ice, carbon dioxide, ammonia, methane, the usual stuff you'd expect from frozen leftovers of planetary formation. 3I Atlas doesn't have the usual signature, not even close. The Keck 2 telescope in Hawaii detected something that made astronomers do a double take. The object is emitting approximately 4 grams of nickel per second. Pure nickel. But here's the kicker. No iron. Zero. Not a trace of it. Every natural comet ever observed shows iron when it shows nickel. They come together. They're bonded in the rock and ice. You don't get one without the other in nature. It doesn't happen. Except it's happening right now with 3I Atlas. When nickel appears without iron in these specific conditions, it forms something called nickel tetracarbonyl. The chemical formula is NiCO4 if you want to get technical. This compound is toxic. It's also exclusively known from industrial processes here on Earth. We use it in aerospace manufacturing to create metal coatings that enhance surface durability on spacecraft components. It's not something you find floating around in space naturally. Dr. Avi Loeb from Harvard University, one of the most prominent astrophysicists studying interstellar objects, put it bluntly. He said there is only one place where that is known to exist, and that is in industrially produced nickel alloys. This was never observed for any other object, not any comet, not any asteroid, not any interstellar visitor. Nothing. Just 3I Atlas. Now let's pile on another chemical mystery. The James Webb Space Telescope analyzed the coma around 3I Atlas. That's the cloud of gas and dust that surrounds a comet's nucleus. Normal comets are mostly water ice. About 80% of their volatile composition is water. That's what you expect. Dirty snowballs from the edge of the solar system, packed with frozen water from billions of years ago. 3I Atlas is only 4% water. 4%. The rest, 95% of its volatile composition, is carbon dioxide. The ratio of carbon dioxide to water in this object is 81:1. That's among the highest ever recorded in any comet. It's so unusual that scientists don't have a good natural explanation for how a comet could form with that composition. Where in the universe do you get conditions that create an object that's almost entirely carbon dioxide ice with barely any water? What kind of stellar system produces that? Nobody knows. And that's the problem. Part 2, the trajectory. Okay, chemistry is weird. Maybe there's a natural explanation we haven't thought of yet. Maybe this thing formed in some exotic environment or in a molecular cloud with weird conditions. Fine, let's set that aside for a second. Let's talk about how this object is moving. Because the trajectory of 3I Atlas is statistically absurd. When something enters our solar system from interstellar space, it can come from literally any direction. Space is three-dimensional, right? It's a sphere of possible entry angles. Most interstellar objects should arrive at random angles, random orientations, because they're coming from random places in the galaxy. The odds of an interstellar object arriving perfectly aligned with our solar system's orbital plane, the flat disk where all our planets orbit, should be incredibly low. 3I Atlas is aligned within 5 degrees. 5 degrees. The probability of that happening by chance is 0.2%. Not impossible, but seriously unlikely. 1 in 500. But wait, there's more. It's traveling in a retrograde orbit. That means it's moving opposite to the direction our planets orbit around the Sun. This retrograde motion is actually useful if you wanted to design a trajectory that allows close approaches to multiple planets while requiring minimal energy for adjustments. It's almost like the orbit was chosen specifically to maximize planetary encounters with minimal fuel expenditure. Oh, and the orbital eccentricity. That's the measurement of how stretched out an orbit is. A perfect circle has an eccentricity of 0. Earth's orbit has an eccentricity of about 0.17, nearly circular. 3I Atlas has an eccentricity of 6.137. That's the highest eccentricity of any known interstellar object. The path is so hyperbolic that it's almost a straight line through the solar system. It's barely bending at all as it passes the Sun. At perihelion, its closest approach to the Sun, which happened on October 29, 2025, it came within 1.36 astronomical units. That's about 203 million kilometers, right between Earth and Mars. Close enough to get a good look at the inner solar system. Close enough to do something. And here's where it gets even stranger. Part 3, the timing. October 29, 2025. Remember that date. That's when 3I Atlas reached perihelion. That's when it was closest to the Sun, soaking up the most solar energy, experiencing the most intense heating. It's also the exact moment when Earth-based telescopes couldn't see it at all, because it was in solar conjunction, hidden directly behind the Sun from our perspective. This is what physicists call the optimal Oberth maneuver window. If you're a spacecraft and you want to change your velocity with maximum efficiency, you do it at perihelion. The closer you are to the Sun when you fire your engines, the more speed you gain for the same amount of fuel. It's basic orbital mechanics. It's how we send probes to the outer solar system. We slingshot them around planets or the Sun at the closest possible point to get the biggest boost. 3I Atlas reached this optimal window while completely hidden from observation. Dr. Loeb called this either a mere coincidence or a result of orbital design and basic astronautics. Those are the two options: random chance or intentional planning. During perihelion, the object was receiving approximately 33 gigawatts of solar energy across its estimated 5-kilometer diameter. To put that in perspective, that's equivalent to 1/3 of the United States' total nuclear power generation. That is an enormous amount of energy. Enough to power advanced communication systems, enough to run propulsion mechanisms, enough to do pretty much anything a large technological object might need to do. And we couldn't see what it was doing.
Part 4. The Anti-Tail. Before 3I Atlas disappeared behind the Sun, astronomers noticed something that broke the fundamental rules of how comets work. It had an anti-tail, a jet of material pointing toward the Sun instead of away from it. Comets have tails because the Sun's radiation pressure and solar wind push gas and dust away from the nucleus. That's basic physics. The tail always points away from the Sun. Always. Sometimes you get what looks like an anti-tail, but it's usually just an optical illusion based on the angle you're viewing from. When you account for perspective, it's still pointing away from the Sun. You're just looking at it from a weird angle. The anti-tail on 3I Atlas wasn't an optical illusion. It was real. A genuine jet of material being expelled toward the Sun, defying the radiation pressure that should have been blowing it the other way. The Nordic Optical Telescope confirmed it. This was an actual physical phenomenon, not a viewing trick. What could cause that? Maybe gas venting from the surface at just the right angle. Maybe unusual rotation creating asymmetric outgassing. Maybe some internal process we don't understand yet. Scientists started proposing explanations, each one requiring special conditions that we've never seen in any other comet. And then something even weirder happened. When 3I Atlas emerged from behind the Sun, the anti-tail was gone. In its place was a normal tail, pointing away from the Sun like it's supposed to. The object had developed a conventional comet tail during the exact period when we couldn't observe it.
during the exact window when it was at perihelion, when it had maximum solar energy available, when it could theoretically perform any kind of maneuver without us watching. The official explanation is that the delayed emergence of the normal tail resulted from unusually large dust particles, about 100 micrometers in size, being ejected at slow speeds of around 5 meters per second. These particles would take time to respond to solar radiation pressure, so the tail appeared late. That's the natural explanation. It's plausible. It could be what happened. But the timing is suspicious. The change happened precisely when we couldn't see it happen. Part 5. The Encounters. While 3I Atlas was playing hide-and-seek behind the sun, something else was happening. It was making close approaches to other objects in the solar system, close enough that spacecraft could observe it. Not just observe it from a distance, but potentially pass through its tail, collecting direct samples of whatever this thing is shedding into space. On October 3, 2025, about 3 weeks before perihelion, 3I Atlas passed within 28 million kilometers of Mars. That might sound far, but in astronomical terms, that's incredibly close. Multiple spacecraft orbiting Mars had front-row seats. ESA's Mars Express and ExoMars Trace Gas Orbiter, NASA's MAVEN, and other Mars orbiters all turned their instruments toward the visitor. They captured detailed observations, measurements, spectra, images. All that data is still being analyzed. But here's what's even more interesting. 2 spacecraft, completely unrelated to Mars, were positioned to fly directly through the tail of 3I Atlas between late October and early November. ESA's Hera mission and NASA's Europa Clipper. Pure coincidence. These missions were already traveling through space on their way to other destinations, but their trajectories happened to intersect with the extended tail of the comet. This is huge. If those spacecraft detected ions from 3I Atlas's emissions, we'd have direct samples of interstellar material for the first time. We'd know exactly what this thing is made of at a molecular level. We'd potentially settle all the questions about the weird chemistry, the nickel without iron, the carbon dioxide dominance. The data could confirm it's a natural comet with exotic composition, or it could reveal something else entirely. As of now, we're still waiting for the full analysis of what Hera and Europa Clipper found. The preliminary results haven't been fully released, but scientists involved in the missions have said the data is surprising. That's the word they used, surprising. Not confirming what we expected. Not ruling out anything, just surprising. Part 6. The Classification. Dr. Avi Loeb has been one of the most vocal scientists about the possibility that some interstellar objects might not be natural. He's proposed a classification system for potentially artificial objects, ranking them from 1 to 10. A ranking of 1 means clearly natural, just a rock or ice ball. A ranking of 10 means confirmed hostile alien technology. It's a spectrum of how weird something is compared to what we'd expect from nature. Based on 7 documented anomalies with 3I Atlas, Loeb currently ranks it at level 4. That's unusual, but not conclusive. Not proof of anything artificial, but weird enough that we can't ignore the possibility. Let's go through those 7 anomalies one by one, because they add up fast. Anomaly 1, orbital alignment within 5 degrees of the ecliptic, a 0.2% probability for a random interstellar object. Anomaly 2, the anti-tail geometry that pointed toward the sun, violating standard cometary physics, then disappearing when we couldn't observe it. Anomaly 3, the unprecedented size. 3I Atlas is estimated to be about 5 kilometers in diameter. That's massive for an interstellar object. Most of the ones we've detected are small, under a kilometer.
This thing is huge, potentially weighing over 33 billion tons based on density. Anomaly 4, the planetary flyby trajectory that brought it close to Mars and positioned it perfectly for multiple spacecraft encounters. Anomaly 5, the exotic chemistry, nickel without iron, 95% carbon dioxide, compounds that only exist in industrial processes on Earth. Anomaly 6, extreme polarization in the light reflected from its surface, indicating unusual material properties that don't match typical cometary dust and ice. And Anomaly 7, the arrival direction. When you trace back where 3I Atlas came from in the sky, it's within 9 degrees of the source location of the famous WOW signal from 1977. Remember that? The strong narrowband radio signal detected by the Big Ear radio telescope? The one that lasted 72 seconds and was so strong and unusual that the astronomer who found it wrote "Wow" on the printout. The signal that's never been detected again. The one from an unknown source that some people think might have been artificial. 9 degrees away. The probability of that alignment being random is about 0.6%. Again, not impossible. But when you start stacking these low probability events on top of each other, the combined improbability starts to look suspicious. So here's the question that's keeping scientists up at night. Here's the scenario that Dr. Loeb and others are seriously considering, not as science fiction, but as a hypothesis that needs to be tested. What if 3I Atlas is a mothership? Stay with me here. If an advanced civilization wanted to explore other star systems, sending one massive probe might be more efficient than sending many small ones. You pack the mothership with everything you need for a long journey: power systems, shielding, navigation, and most importantly, smaller probes that can be deployed when you reach your destination. The mothership does the hard part, the centuries or millennia of interstellar travel. Then, when it reaches a star system of interest, it releases many probes during perihelion, using the Oberth effect to redirect them toward planets with minimal energy expenditure. The mothership continues on its original trajectory and exits the system. The many probes, much smaller and harder to detect, adjust their courses and head toward specific targets, like Earth. If 3I Atlas deployed probes during perihelion on October 29th while hidden behind the Sun, those probes could reach Earth within months. They'd be small, maybe a few meters across, traveling at high velocity. They wouldn't need much energy to adjust their trajectories because they got their initial boost from the Oberth maneuver at the perfect moment. And we wouldn't have seen them launch because we couldn't observe 3I Atlas during that critical window. Dr. Loeb put it like this: if 3I Atlas is a massive mothership, it will likely continue along its original gravitational path and ultimately exit the solar system. In that case, the Oberth maneuver might apply to the many probes it releases at perihelion towards solar system planets. This isn't wild speculation. This is a serious scientific hypothesis based on observed data and established physics. It's unlikely, sure, but given everything we've seen, it's not impossible. Now, let's be clear. Most scientists think there's a natural explanation for all of this. The exotic chemistry could result from formation conditions in 3I Atlas's home system that we simply haven't encountered before. The anti-tail could be explained by unusual dust grain properties and ejection dynamics. The trajectory alignment could just be one of those 1 in 500 coincidences that happen sometimes. When you observe enough objects, eventually you'll see some really unlikely combinations of features purely by chance. Critics of the artificial hypothesis point out that individual anomalies, while statistically unlikely, don't constitute proof when considered independently. You need extraordinary evidence for extraordinary claims. And right now, the evidence is puzzling, not definitive. Nobody's saying we've confirmed alien technology, but what people are saying is that we can't rule it out yet, and that's significant. Right now, as you're watching this, 3I Atlas is moving away from the Sun. It's heading outward toward the outer solar system. On December 19, 2025, it made its closest approach to Earth at a distance of 269 million kilometers. Still too far for detailed visual observation with most telescopes, but close enough for intensive spectroscopic analysis and radar observation if we pointed the right instruments at it. Astronomers around the world did exactly that. Every major observatory that could track it did. They captured spectra, measured light curves, looked for any changes in brightness or composition that might give us more clues. All that data is being analyzed right now. We're going to learn a lot more in the coming weeks and months as researchers publish their findings. In March 2026, 3I Atlas will pass near Jupiter. Not as close as the Mars encounter, but close enough for Jupiter's enormous gravitational field to potentially alter its trajectory slightly. This will give us another observation opportunity with spacecraft in the Jovian system, Juno, ESA's JUICE mission when it arrives, potentially others. Long-term monitoring through this encounter will tell us definitively whether the observed anomalies are persistent features of the object or just transient phenomena we happen to catch during a weird moment. If 3I Atlas continues to behave like a normal comet, gradually brightening and fading as it moves, showing standard outgassing patterns, then we can probably chalk up the weird chemistry and trajectory to natural processes we don't fully understand yet. Nature is strange sometimes. The universe is full of edge cases and rare configurations. Maybe this is just one of them. But if new anomalies appear, if the object does something unexpected during the Jupiter encounter, if we detect any kind of course correction that can't be explained by gravitational interactions and outgassing, then we have a problem. Then we have to seriously consider that we're dealing with something that isn't entirely natural. And here's the thing that bothers me most about this whole situation. If 3I Atlas did release many probes during perihelion, we wouldn't necessarily know. They'd be too small to detect directly unless they passed very close to Earth or reflected sunlight in just the right way. Our current space surveillance systems are designed to track satellites and debris in Earth orbit, not tiny interstellar probes approaching from arbitrary angles. We might not see them coming until they were already here. This whole situation raises questions that go way beyond one object passing through our solar system. It's making us rethink how we look for evidence of extraterrestrial intelligence. For decades, SETI, the search for extraterrestrial intelligence, has focused primarily on radio signals. We've been listening for broadcasts, for intentional messages beamed across the galaxy. We've been assuming that if aliens wanted to communicate, they'd do it with electromagnetic radiation, with signals we could detect with radio telescopes. But what if that's not how advanced civilizations explore? What if the most efficient way to study other star systems is to send physical probes? Think about it from a practical standpoint. If you want to really understand a distant planetary system, you need to be there. You need to sample the atmospheres, analyze the geology, observe the planets up close over time. A physical probe can do that. A radio message can't. And here's the clever part. If you're an advanced civilization sending probes to thousands of star systems, you'd want them to be self-sufficient. You'd design them to last for the incredibly long journey through interstellar space, millions or billions of years. You'd make them blend in with natural objects so they don't attract attention immediately. You'd have them arrive quietly, observe from a distance, maybe deploy smaller scouts to get closer looks at interesting planets. From the outside, these probes might look exactly like interstellar comets or asteroids, chunks of ice and rock tumbling through space. The only way you'd know they were artificial is if you looked closely at the details, the trajectory, the chemistry, the timing of their maneuvers. Sound familiar? 3I Atlas might be a natural comet. It probably is. But it's forcing us to develop the tools and frameworks to distinguish between natural interstellar objects and potential artificial ones. We're creating classification systems, defining what anomalies we should look for, establishing protocols for what to do if we detect something that really can't be explained naturally. This is important work, regardless of what 3I Atlas turns out to be, because we're going to see more interstellar objects. As our detection capabilities improve, we're going to find dozens, then hundreds of these visitors passing through our solar system. Most will be natural, but if even one of them is artificial, if even one is a probe sent by another civilization, that changes everything. That's first contact, not through a radio message, but through archaeology, finding an artifact left for us to discover.
So, where does that leave us? We have an object, 3I Atlas, that's 710 billion years old, traveling on a statistically unlikely trajectory, made of chemicals that don't appear together in nature, arriving precisely when it can perform optimal maneuvers while hidden from observation, approaching multiple planets, and coming from a direction near the source of an unexplained radio signal from decades ago. Each individual anomaly has a potential natural explanation, but all of them together? That's where it gets uncomfortable. That's where scientists start using words like unprecedented and surprising and unusual. That's where someone like Dr. Avi Loeb, a respected Harvard astrophysicist, starts publicly discussing the possibility of artificial origin. We won't know for sure until we get more data. The spacecraft encounters, the spectroscopic analysis from Earth-based telescopes, the long-term monitoring as it leaves the solar system. All of that will give us a clearer picture. But right now, in this moment, we're in a state of uncertainty. We're waiting to find out if we just witnessed a really weird natural comet, or if something far more significant just happened. The ancient Voyager continues its journey, carrying secrets from an era when the universe was young. Whether it's a cosmic time capsule showing us what the early galaxy looked like, or a designed explorer from a civilization we can't even imagine, 3I Atlas has already accomplished something remarkable. It's forced us to ask the question we've always wondered but rarely had concrete reason to seriously consider. Are we alone in the universe? Or are we just now starting to notice that we're not? The data is still coming in, the analysis continues, and somewhere out there, 3I Atlas is moving toward the edge of our solar system, heading back into the vast darkness between stars. If it is just a comet, it's the strangest one we've ever seen. If it's something else, then everything just changed, and most of us don't even know it yet. Over the next few months, watch the news. Watch for updates from observatories and space agencies. Because if new information drops that definitively points one way or the other, you'll want to know. You'll want to be able to say you were paying attention during the moment when humanity might have encountered its first confirmed visitor from another world. If this got you thinking, hit subscribe, because this story isn't over yet.